Hi, this is our last video on surface area. This is application to surface area, and you'll be happy to know it's a very short video. Okay, we want to be able to distinguish between finding lateral surface area and total surface area in application problems. Surface area is the area of the faces of a three-dimensional solid. The lateral area is the sum of the lateral faces, and the total area is the sum of the lateral faces and the base or bases, as it may be depending on the problem. So now let's look at, first they're going to give us a review of the formulas here. So you might want to take a picture of this or be able to refer back to, here are the formulas for lateral and total of prisms, pyramids, cylinders, and cones. All right, so this first problem deals with, we have two different configurations of 4 juice boxes that are going to be wrapped together with plastic wrap. And we want to look at the two of them, and plastic wrap would be the surface area, and determine which would be the better fit. So let's start with the first one. So the formula is pH plus 2b, where P is the perimeter of the base and the capital B is the area of the base. In the first one, we will call the top and bottom the base, because remember, the bases are 2 parallel congruent polygons. So this is a rectangle. So we can see that the width of this rectangle is 5, and then the length of the rectangle, well, each box is 7, and there's 4 of them, so that would be 28. So if we find the perimeter of that base, it is going to be 66. And then the height is not part of the base, so this would be the height of the prism. So the lateral surface area is the 66 times 10, but we want the total to that. So to that, we're going to add 2 times the area of the base. And so that would be 2 times 5 times 28, which is 140. So if we add this together, we're going to get 660 plus 280. And when you add that, you get 940. So this would be 940 centimeters squared. Okay, so that is the surface area of this first one. I'm going to write that right here. 940 centimeters squared, so that I can erase right here and have room to do the next one. So again, on the next figure, where it's just stacked differently, the formula is the same. So pH plus 2b. So I'm going to call the top and bottom again the base. So this would be the base. And so again, the width of this is 5, but it is only 2 wide, so this would be 14. So the perimeter of that base is 38. Now what is the height? Well, it shows 1 is 10, but it's stacked too high, so it would be 20. So this is going to be 38 times 20. And then to that, we're going to add 2 times the area of the base, 5 times 14, which is 70. Okay, and so if we do 38 times 20, we get 760 plus 140. And if we add that, we get 900 centimeters squared. And so if you look and see which would be the better, well, arrangement 2, this one, is the better one, and it's better because it is the surface area is 40 centimeters squared less. So we would use less shrink film to wrap the second configuration. And that is a good example of why you would actually use surface area in a real application problem. Okay, let's look at the next example. Here it says Jorge has to wrap a gift. Both of these containers will hold his gift. Which container would allow him to use the least amount of wrapping paper? This one's probably a little more obvious, but we have a triangular prism and we have a rectangular prism. So here, this triangle here, let me draw the triangle separately here. So this is just this base right here, and it shows us that this is 10. Okay, it also shows the height here, and it tells us that that is 5. So they've rounded this off a little bit. Now, what about the sides of that? Well, because the definition of bases is that they are congruent and parallel, the 7s that we see down here, we can also put here because they have to be congruent. So now we can find the same formula, pH plus 2b. So the perimeter of this triangle is 24. Now the height of the prism is going to be 30. And to that we're going to add 2 times the area of the base. And so the base is this triangle, and it is base times height divided by 2. So 10 times 5 divided by 2. And so that's going to be 25. And so 24 times 30 is 720. And to that we're going to add 2 times 25 or 50. And we'll see that the surface area of this figure 1 is going to be 770 centimeters squared. And so now we're going to look at figure 2 and see what we come up with. So again, let me erase this so I can have some room to work. Okay, same formula, pH plus 2b. And now we will call this the base. And so this has dimensions of 10 and 5. And so the perimeter of that base would be 30. The height is the same, it's 30. And to that we're going to add 2 times the area of the base, or 10 times 5, which is 50. And so now this is 900 plus 100. And so this one is going to be 1,000 centimeters squared. So in this one, it's pretty obvious that container 1 is the better container because the surface area of this one is 230 squared centimeters less than figure 1. So if we're trying to minimize the surface area, we would want to use the first number 1 as the better packaging option. Okay, example 3. The owners of Neatly Packaging Company want to make a cylindrical container that has the dimensions shown. What is the approximate lateral surface area? So in this time, be careful and see what they're asking for. Here they're asking for lateral for the packaging label because the label's just going to go on the outside. So here the formula is 2 pi RH. And so this is 2 times pi. They give us the diameter. They don't give us the the radius, so we need to divide that by 2, and that's going to be 1.75. And then the height is 12. And so we're going to multiply the 2 times the 1.75 times the 12, and we're going to get 42 pi. Now, sorry if this is so messy, but then they say record your answer and fill in the bubbles, but they want it to the nearest hundredth. So when they say that, they mean please put it in your calculator. They do not want the answer in terms of pi. And if you have a calculator that allows you to, at this point we don't want to use 3.14 for pi. We want to actually use the pi symbol and be a little more exact. So 42 pi is approximately 131.947 . But if we look, it says to the nearest hundredth, so that would be 131.95. So 131.95. And I'm not going to try and bubble it in, but that would be your answer. Okay, I think we just have one more. Now on this one here, you have to think a little bit. It says JJ's Pizza uses a rolling pin that is 30 centimeters in length and has a 10 centimeter diameter. So let me kind of try and draw that. So it is cylindrical, so it's going to look like this. And it says that it is 30 centimeters in length and has a 10-inch diameter. Now remember, diameter isn't what we need. We need radius, so half of 10 is 5. Now it says how much of the pizza dough will be spread with one revolution of the rolling pin. So you have to think about that. If you're rolling a rolling pin, the ends of the rolling pin are not going to touch the pizza dough. So you have to think yourself and realize that what they want is just the lateral. So 2 pi RH. So this is going to be 2 times 5 times the radius. That 2 times pi. It's a pi. Let me fix that. I'm sorry these pens are so hard to write with here. Okay, so 2 pi times 5 times 30. And so that's going to be 153. It's going to be 300 pi. Again, they ask us to round to the nearest hundredth. So you're going to take that and put it in the calculator. And you will get, and again, try and use pi, not 3.14. 300 times pi is approximately, I get 942.478. And so if we round that off, we're going to round that off to 942.48. Okay, so those are all the examples, and there's a worksheet, and good luck. And again, always email me if you have questions.